Hi guys, this is going to be an attempt to try to teach you to do quantum numbers, but in order to do quantum numbers we're going to have to review really quickly electron configuration and orbital notation. So I'm going to start off with that. We're going to do the electron configuration for, let's do silicon over here. So element number 14. So remember we have to go through the periodic chart. So we're going to have to start off with the 1 and S. So the electron configuration for silicon is going to be 1 S, and we use both. Remember also helium could be written over here, so you'll have to forgive my handwriting. I'm trying to figure out this tablet thing. So 1S, 2, and then the 2S, both of them. So 2S, 2, go across to the, this is the 2P, so 2P6, 3S2, 3S2, over here 3P6, nope, 3P1, 2. We're only going to that one right there, so 3P2. Okay, that's the electron configuration for silicon. Now we're going to write the orbital notation. Remember, either draw lines or give me some space so I can follow what you're doing. This is kind of messy, but remember there's one shape or one orbital for the S sublevel, so you draw one line for the shape or orbital for the S sublevel. And there are three shapes, the PX, the PY, and the PZ for the P level. So remember, PX goes like this, PY goes on the y-axis, and the PZ would go in and out on the z-axis. So 3 orbitals in the P sublevel. And each orbital, no matter what shape, what S, P, D, or F, can only hold 2 electrons. So there's 2 electrons here. The first electron spins up, and you do the up arrow, and the second electron spins down. Same thing here, up and down. When we get to the P level, according to Hund's rule, you can only have 1 electron in each level before you start doubling up. So we start off, put 1 electron here. All right, that's 3 of the electrons. So now we have to do the 4th one. It's going to go back to the beginning and spin down. And notice I went all the way back to the left and came down. So there we have all 6 electrons. Here we have the S level that can only hold 2 electrons because it only has 1 orbital. The P level again, but this one only has 2 electrons. So I don't put them both in this first orbital because they have to be separated in order to fulfill Hund's rule. So the first one goes in this sublevel orbital, and this one goes in this orbital, and that means this orbital is left blank, and you need to show me that that is blank. So this is the electron configuration for silicon. So I'm going to rewrite that on a blank sheet of paper, and then we're going to work out the quantum numbers. So let me pull up a blank sheet of paper now. Discard this. Blank paper. Let's see here. Page, paper style, plain. And we're going to make it big. All right. So for silicon, it was 1s2, 2s2, 2p6, 3s2, and then 3p2. Okay, now let's do the orbital notation was the S, the 2s, 1, 2, 3, 4, 5, 6, 1, 2, and then the 3 P's, but only 2 electrons. Now what I want you to do when you're doing quantum numbers is circle the electron you're going to use. So I'm going to change the color for a second here. I'm going to circle this one. I want you to, whatever is the last electron that you write, I want you to do the quantum number for that one, but I need you to circle it to make sure that I'm following exactly. Now here's the deal with quantum numbers. There's 4 quantum numbers. The first one is the N, and the N is just the principal energy levels. And so that's the numbers on the left hand of your periodic chart. Let's see. That would be 1, 2, 3, 4, 5, 6, and 7. In the middle, that would be these 3s. And on this side, see there's silicon, it would be the 3. So it's the energy level along the periodic chart, okay? So go back down to here. So there's 7. 1, 2, 3, 4, 5, 6, and 7. All right. The second one is where you tell me the sublevel, and it's got a little L, and it's an azimuthal. Don't worry about the name too much. It's just the sublevel. Okay. Now let's remember that the sublevels are S, P, D, and F. And the S sublevel gets a number of 0. I don't know why they started with 0 and not 1, but they did. The P gets a 1, D gets a 2, and F gets the number 3. And the next quantum number is the magnetic quantum number. It's a little m. And this one is probably the most confusing quantum number. I like to tell you that it's the position. The position within the sublevel. So S, notice that S only has one orbital, so the only position that the electron could be in is in this one spot, and that's called the 0 spot. For this one, think about the number line. 0 is always right in the middle, and then right next to it would be +1, and then a +2, and so forth. And on the other side would just be the opposite. -1 and a -2. So think about that. The 0 position is, if there's only one position, you always put the middle position right on the 0 spot. All right. For the P, remember there are 3 orbitals in the P sublevel: 1, 2, and 3. And so the 0 spot, the middle, is the middle spot again. So what is immediately to the left, or sorry, to the right of 0? It's the +1 position, and to the left is the -1 position. And for the D, there are 5 orbitals. So the middle position is 0. This would be the +1. This would be the +2. -1 and the -2 position. And then for F, there are 7. 1, 2, 3, 4, 5, 6, and 7. So we're not going to worry about using the F too much, but you could see this would be 0, +1, +2, +3, -1, -2, -3. All right, that's the position. And then the fourth quantum number, is the spin, the easiest one. It's an M sub S. It's a spin number. And so that's really easy. If it goes up, the quantum number for the up spin is a +1/2. And you actually have to write all of that. You have to write the plus sign. If it's a down spin, it's a -1/2. And you have to write all of that, including the down spin. So what is the quantum number for this electron in silicon? Well, the first is the N number. The N number is the principal energy level, and this electron is in the 3rd energy level. So we write 3. Now notice that silicon has other electrons, like this electron is in the 2nd energy level. And all of these electrons are in the 2nd energy level. These electrons are in the 1st energy level. These electrons are in the 3rd energy level. So this is like telling me your state. What is your state? I'm in the 3rd energy level. Okay. All right. Then you put a comma. The second quantum number is the sublevel, and so this is a P. And so according to the sublevel, P is 1. Remember, S is 0, P 1, D 2, F 3. So this is a 1 for the P. All right, so this is now the position. If we have P, we have to look out the position. Look at this position. It's in the P. So this would be the 0 position, and this would be the +1 position, and that would be the -1 position. So it's pretty easy. Just put the 0 in the middle spot, and +1 and -1. You know what position it's in. It's in the 0 position. And then it's spinning up, easy. +1/2. And that is the orbital, the quantum number for silicon. Okay, let's try doing another one. I'm going to erase part of this. Let's get rid of silicon. And this time I'm going to do the abbreviated notation for whatever element. I'm going to pick an element off the periodic chart. Okay, let's go look at the periodic chart. All right, let's do the abbreviated electron configuration and orbital notation, and we're going to do it for one of the D block elements. Let's do cadmium. No, I don't want to do cadmium. Let's do molybdenum. Molybdenum, number 42. Okay, let's look at that. Now, if you see that, we have to go through the 1s. So it'll be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, because I'm going down to molybdenum, number 42, 4p6, 5s2, 4d1, 2, 3, 4. Okay, that would be the long one, but I'm going to write the abbreviated, so I go up a level all the way to the edge, krypton. So let's go back over here, and let's write for molybdenum, right at the top here, put it back in pen mode. Molybdenum. We're going to do the abbreviated form, so we're going to have krypton. Okay, and go back and look at it one more time. Looks like 5s2 and 4d1, 2, 3, 4. 5s2 and 4d4. So 5s2 and 4d4. Okay, let's write the orbital notation for this. The S has one shape, one orbital, so up and down because it has both electrons filled. The D has 5 shapes. Remember, for S, P, D, and F, it's 1 for S, it's 1 for S, 3 for P, 5 for D, and 7 for F. So 1, 3, 5, 7. And number of electrons would be 2, 6, 10, and 14, or 2 times 1, 2 times 3 is 6, 2 times 5 is 10, and 2 times 7 is 14. So 5 shapes, 5 different orbitals for D. 1, 2, 3, 4, 5. But we only have 4 electrons that are filling these up. We have to put 1 in each spot, and we can't double up until they're full. So 1, 2, 3, 4. And the last one that you wrote down, you circle. Okay, now we're going to do the quantum number for this electron. Energy level N. Okay, remember it's N first, so the energy level 4. Next is the sublevel. What sublevel it's in? It's in D. So if S is 0, P is 1, D is 2. What position? Well, that's the middle, so that would be the 0 position. So that would be the +1 position. See, that would be the +2 position, the -1, and the -2. And it's spinning up, so +1/2. Every electron has a different address. This electron would be energy level 4, the 2 for the D sublevel, 0 for its position, and +1/2. So the only difference between this electron and this electron is the position number. Every electron has its own position number. Okay, we'll do one more. It'd be nice if this thing was, there we go. Can I make the eraser? Yeah, bigger. And that'll be our end our tutorial on quantum numbers. Let's look back at this one more time. Let's pick, that was molybdenum. This time I'm going to go ahead and pick, I think that's palladium, PD. I don't have that one memorized, sorry. I know PB is lead, but I'm not doing lead, so that's PD. We're going to do that one, number 46. Okay, it'll have krypton because we go up a level and all the way to the end. Krypton, and then that's the noble gases, you know, the noble gas configuration, sometimes they call it that. So krypton, and then it'll have 5s2 and 4d, 1, 2, 3, 4, 5, 6, 7, 8. 4d8. Okay, so, whoops, not lead, palladium. Erase that. Try again. Okay, krypton, always put it in brackets, the noble gas that was finished. 5s2, 4d, and I already forgot. How many was it? 1, 2, 3, 4, 5, 6, 7, 8. 4d8. Okay. Alright, now let's write the electron configuration. Okay. We'll draw a line to separate them. The 5 shapes for the D. 1, 2, 3, 4, and 5. 8 electrons. 1, 2, 3, 4, 5. You have to do that first. Now they're all full, so I have to go back to the beginning and double up and down spin it. 6, 7, 8. That's what Hund's rule tells us. Use something to circle the electron I'm going to be using. I'm going to write the quantum numbers for this electron. Okay, energy level 4. That's the N quantum number. D is the L, the azimuthal, which is the sub-level, and D's are 2. So, position, well, 0, plus 1, and plus 2, and the minus 1 and the minus 2. This is in the 0 position. And it is spinning down, so I'll write minus 1/2. And that is how you do quantum numbers. Sorry for the sloppy writing. I'm trying to work with this this stylus, and I'm not able to write directly on the screen. So, okay, so that is how you do quantum numbers. Next, what we're going to do is talk about the dual nature of light and using the 2 formulas. So we'll do that one on a separate video.